Okay, we can go ahead and get started here. Welcome everyone to Developer Week 2024 Virtual Edition. It is my pleasure to introduce our next speakers, Amy Simonson, Marketing Manager, and Carl Moberg, CTO and co-founder of Avassa. Amy and Carl, y'all can go ahead and take it away.
Thank you so much for the introduction and welcome everybody to our presentation today. We lovingly call it a developer self-service experience for Edge and IoT come true. We had the opportunity to present this live last week at the Developer Week physical event, so we've done it once, and hopefully we can add some flair here. As you can see from the title, what we're going to do here is tie what we believe to be maybe up until now 2 worlds together. The one world is the application-centric world of developer self-services. And of course, the background that Amy and I have, which is to work with teams in companies that have the need to manage applications in, broadly speaking, edge and IoT environments. So that's the topic of this presentation here today. And I'm really trying to avoid repeating too much of history for you guys, but there's a little bit of, I guess, learning we can all take from the last couple of kind of almost decades about how to think about the emergence of the edge. If we think back to the kind of on-premises times of 2000s, of the early 2000s and all the way to 2010, we can surmise, or we can posit that there's a couple of things that really was a game changer when the cloud paradigm hit the industry. And there's a couple of things that will come into play in kind of future, lookings here that I would like to highlight. So this is not a comprehensive or complete description, but a couple of things that I find to be very interesting when looking eventually at the edge here. The first one to me was the fact that cloud computing really made location way less important than before, maybe at some sort of continental level, but whether your application is running on a particular side of a continent or a particular side of a nation, and maybe even more important, which computer inside of a data center that an application ended up stopped being a thing, stopped being something that you needed to take into account. A lot of clever developments, both on the networking side, but certainly also on how applications are placed and how traffic is matched with applications, really made this an out of sight, out of mind aspect for most people. And that came, of course, as a side effect of the fact that we were looking at huge, absolutely massive data centers, very, very big, well-protected, well-ventilated, and well-provided data centers that could harbor, or does harbor, just an insane amount of compute and storage and all the kinds of resources that you need. And again, build-outs of those things were also not something that you, as a developer or anyone, needed to care for, except if you were the person, of course, building the data center for that cloud provider. And what that led to was, again, in most practical senses, an abundance of resources for applications. And again, of course, this didn't mean that we invented unlimited resources. It just meant that whenever you needed resources, you could ask for it in a programmatic fashion. You could avoid meetings. You could avoid lengthy wait times. You could simply scale up or down or in and out based on the abstractions or based on the function of the cloud you were running on. And those 3 things, I would say, contributed to quite an impressive kind of shift in the way we organized our application and IT teams, what kind of processes we had in place, and what kind of tooling that we started focusing on to take into account these kind of critical changes, as opposed to the way we were running things before, when we had, locally owned and locally petted and cared for servers and a lot of manual steps. So now we could focus on processes around the fact that resources were readily available globally, and we could start build on tooling that took that into account, and that really improved both developer and IT team kind of life experience or work experience. Now, if we look at what's going on I guess, in the kind of more forward-looking type of edge that we're talking about here, which is kind of a step away from, I'd say, traditional IoT style or embedded systems edge, rather towards running computer programs on top of server style or open platforms like x86 and ARM platforms, usually on Linux, but in a very, very distributed fashion, kind of on-prem, hundreds or thousands of locations. There's a couple of things that makes that environment a little different than the cloud. And my point that I'm going towards here is that it's different enough that it may create a little bit of hassle as we take into account how we need to work with that. And I guess one of the first things is that in most edge environments, location actually has a point. It carries meaning. So if you're running a computer program somewhere, maybe in a retail store or in a hospital or on an oil rig or oil platform, there's a point to why you're running it in that particular location. So it's not a matter of being able to, for example, redeploy or fail over to another location, because again, it's usually the physical or at least the geographical closeness to whatever users or other sources of data that you have. That is the point of running things at the edge. So location matters. And of course, if we are running across many locations, it's kind of self-evident that you will never have, anywhere near as much compute power in each location. Actually, in most of the scenarios that we're working with in retail and quick serve restaurants, and again, healthcare and oil and gas, energy systems, there's usually a very small set of computers. So maybe, a handful or two, but in very, very many locations. So it's just not just that location matters, but there's also a lot of locations. And for each one of those locations, of course, then resource constraints is suddenly a thing. There is no, or at least very limited, horizontal and vertical scaling. So you have to think ahead a little bit, usually plan ahead, in order to understand what kind of application, roadmap and what kind of resource consumption roadmap can we put up before we actually have to do some sort of hardware scale up, which is usually a fairly, resource intensive and expensive, again, if you're running in hundreds or thousands or tens of thousands of locations. So having resource constraints will also impact the way to think about these things. So, driving this presentation here is, can we use then the setup that we have? Can we reuse the processes, approaches, and tools that we have in place for the cloud? Well, if you also take a step further up and you start thinking about the way people with application mindsets, not only the infrastructure mindset, think about these things, there's another kind of layer of comparison here. If you think about the central cloud, kind of harking back or pointing back to what I just said, as an application developer, as someone managing applications, you can assume rapid elasticity, right? So you can actually rely on the actual infrastructure to take care of any spikes, or for that matter, reduction in traffic towards your applications. That's, again, not something you have to explicitly ask for, nor in the kind of expansion direction or in the kind of pulling in resources direction. The second thing is that with the central cloud, the workloads are usually movable. Kind of mentioned that in the previous slide. The infrastructure of the central cloud can do that for you. If something happens in a particular part of a data center, your application will be moved to another part. If your actual data center is impacted, as we've seen, there's actually features to move your entire workload to other data centers without any manual intervention. And kind of an underestimated thing here, and I kind of alluded to that as well in the previous slide, is that you can rely on perimeter security. As an application person, as a developer, you can rely on the fact that there's usually a fence around the data center. There's usually a locked door and maybe even an armed guard. There's likely, locked cages, and there's all kinds of alarm systems. So you can trust the fact that there's not going to be an adversary kind of standing by the computer where you have your applications. You don't have to protect your data from, for example, from physical tampering if you run on any of the hyperscaler clouds. Now, again, if you take that and you think about the edge from kind of an application point of view, there's a couple of things that come into play that the edge can give you kind of with an equal kind of value, but that's different with the edge. For most of the applications that we see, successfully, fruitfully moving to the edge, one of the major drivers is application autonomy. And what that means in this context is that if you design the application well, then it's going to be independent of upstream connectivity. I usually exemplify by talking about point of sales applications or point of sales functions in a retail store. Obviously, the point of sales functions need to be able to run, you need to be able to sell things, even though you may lose connectivity to the cloud. So if you do this right, you can allow the infrastructure to give you a lot of autonomy, meaning less reliance on, let's say, the internet infrastructure or particular cloud infrastructures. Because if you run it close to the source or close to your users, then you should be able to survive upstream outages. And the second thing, if you're running in hundreds or thousands of locations, what you need the infrastructure to do for you is that it will have to allow for targeted deployments. You can't run every application in all locations with the same configuration at all times. There's usually some sort of selection criteria. If you're running, for example, machine learning or inference servers, you probably want some sort of acceleration with a GPU, so you need your application to run on hardware that actually has that. And if you're running something that relies on a video stream, then obviously you want to put your application only on hosts that can actually offer video streams. And the third thing is that you actually have to think about host-based security, because again, the perimeter is likely going to be much weaker than what you're used to in hyperscaler clouds, right? You can think of a retail store where actually at some locations, your computer may be running just at an arm's length away from someone in the store. You can think of electrical grids where substations are actually pretty small and remote. So actually getting in front of that computer without meeting a guard is not something that is impossible. So you need some sort of host-based security here. So if you think about this kind of in a versus case here, we can look at, what is the assumption? Can we reuse what we have? And since this is a presentation, you can assume, of course, that, I won't say yes here, but I will say that you can probably reuse some of the things that you are using for the cloud. But if you want to really think about how to make this really great for the edge and connect this in a way that you can actually have a good self-service experience, we have to think a little more or maybe a little deeper. So my verdict here will be not comfortably, but let's absolutely dive into it. And if we look in the container orchestration toolbox, this presentation will be a lot about containerized applications. I will say that kind of as a kickoff here, before we dive deeper into the practicalities, that not everything is actually a nail in this context. So container orchestration in the cloud, which I will say is almost like a solved problem. The abstractions are great. People have a lot of experience with that. People have a lot of built-in and investigated knowledge, institutionalized knowledge and tooling around it. But I would say that I will show you, or Amy and I here will show you, that there's a couple of things that are different enough such that you shouldn't try to hammer that screw into the wood, but actually respect the fact that container orchestration at the edge is slightly different, or different enough that it warrants a little bit of thinking. Amy.
Yes, thank you. So to make this come alive a little bit, I would like to introduce you to our team that will join us on this journey towards creating a self-service developer experience for edge and IoT environments. So why not start with a developer? We have an edge application developer on the team, and her name is Applifer Developes. Applifer's job is to plan and design and actually build the edge applications themselves. And she is very passionate about the application layer of the stack. She cares about the features and the value of the applications. That said, she cares much less about the infrastructure-oriented details of the stack. And the work that she do, that is typically what drives the value stream of the enterprise, of the organization, and commonly what initiates the whole edge computing project altogether. And she has a colleague, and his name is Patrick McEngine. he is an edge platform engineer. That means that his job is to plan and design and configure the edge infrastructure. So he is much more passionate about the infrastructure layer and cares a little bit less about the features of the applications. And his job is to be an enabler for application teams. There are usually more than one application team in a large organization, and sometimes even third-party application teams. And sometimes they have to share common infrastructure, and it's Platric's job to make sure that they can do so comfortably and cater to the needs of different application teams at the same time. And Applifer and Platric, they are colleagues and they are a team, and they have different drivers and obstacles when they work, but they are equally challenged by the fact that the edge is a little bit different from the cloud, just like Carl said. And that tends to create a little bit of hassle for them. So let's look at what a day in life could look like for Applifer and for Platric. Applifer, she builds edge applications, and she does so in plural. And when she reaches a point in time when she is ready to deploy an application or a new version of an application, she usually has to do some sort of a manual handover to Platric, where she specifies the application itself and where it's supposed to run. And exactly how manual that handover is, that of course differs in between organizations. It could be fast, but it could also be painfully slow. We recently spoke to an organization that told us that it's about 6 meetings to make sure that one application version is rolled out one time. So it could be a very slow process. And that, of course, slows not only down time to deployment, but also the speed of innovation. Either way, eventually Platric will receive the application. And he might then try to attempt to use the tooling that he already has in place that is purpose-built for the cloud originally. And that is commonly some sort of a Kubernetes-based solution. And while Kubernetes is necessary, it's rarely sufficient to manage the full lifecycle of a containerized application. He'll need additional services to make sure that he can monitor and observe and secure the application across the whole environment. And when he has that set of services, he'll then have to replicate those in each location where the application is supposed to run. Again, that's fine if it's 1 or 2 data centers, but if it's in tens or hundreds or even thousands of locations, it will become quite uncomfortable for Platric. And given the fact that the edge is usually very resource constrained, again, like Carl said, it might not even be possible at times to run a whole set of services in each and every location. I don't think it will matter in this case if I asked Applifer or Platric. This is not what a self-service developer experience should look like, because Applifer, she will continue to develop her applications and bring new versions time and time again. So what do we need here? Well, we need abstractions. And I would like to take a quick moment just to clarify what I mean by abstractions. And to do that, I'm going to use the words of Barbara Liskov. She's the author of Programming with Abstract Data Types. And Barbara says, what we desire from an abstraction is a mechanism which permits the expression of relevant details and the suppression of irrelevant details. So much simpler put, that means that what I want from a system is to see what I actually need to see and nothing else. And this is a fairly mapped out philosophy or way of thinking in the centralized cloud. It is, however, much more exploratory. What are the relevant or appropriate level of abstraction for the edge? So that is what we're going to continue to explore now. Carl.
Thank you. Yeah, so if we take into account what we've kind of talked up until now and kind of try to drill it down and think about if we were to look at the edge, at least the way I described it, from Applifer's point of view, and we try to think about what are the appropriate abstractions to give her to lead ourselves towards a developer self-service experience that, again, as we've kind of set up here, will be slightly, not entirely, but slightly different than the abstractions that is the underpinning of her experience with the cloud. So we can lay it out like this. So if we see here that Applifer has kind of two tasks, and that's usually true, but not always. One is to deploy applications, including, of course, deploying new versions of applications over time. And the second is observe, monitor, if you like, the health of these applications, maybe together with Patrick, or maybe she is on her own with the observability and the monitoring. But of course, in order to do that, she needs two things. Yes, she needs the ability to, of course, describe an application specification, maybe we'll call it that. She can stand on a lot of shoulders from a lot of giants here, declarative specifications of applications. There's an abundance of that. We can borrow heavily. We can even argue that that's a solved problem. That kind of defines the what. What is it that she wants to deploy? What's a little new, or maybe entirely new, based on what we've talked about before, is the where, meaning where should this application run, or under which circumstances should this application run. So kind of building on what I said about the fact that location matters. So there's a point of the location, the configuration of each location, the resource availability ranging from the amount of compute resources we have to extended resources like cameras and GPUs needs to be taken into account if we want to allow, and that's kind of the goal here, Applifer to describe to a system like this through this appropriate abstraction how to deploy and eventually how to monitor and observe an application, so we can make sure that she doesn't have to call or Zoom or fax Patrick. So he can actually go work hard on the infrastructure, but doesn't have to actually take manual interaction with Applifer, and he can focus on installing infrastructure, monitoring the actual infrastructure, and make sure that the infrastructure is as secure as Applifer's applications require it to be. So that's the kind of vision that we're trying to paint here. And of course, a way of thinking about this can be in terms of what our platform engineering friends call a golden path. So we can look at kind of working our way towards a demo setup here. What are the necessary input information in a little more detail, and what should happen when Applifer does something or asks the system to do something for her. Again, as I mentioned, she needs some sort of a what, and that usually takes kind of three aspects or three components. What are the constituent container images that this application should consist of, and what's their relationship to each other? What is the configuration needed to make these containers do whatever they're supposed to do? And if there's any secret or sensitive material, what is that, and which containers should that be exposed to? So that's kind of defining the application itself. And the second thing, again, is the where. And you can think of this where expressions to take at least kind of two layers into account and two types of data into account. One is you can think of site as a regional something or a physical location, maybe a store. And a site can have many hosts. And a host is just an instance of whatever operating system, maybe Linux, that we're running on. So we can say things like, maybe this application that Applifer is going to deploy needs to run on all sites in region Europe, and on each host in all these sites where there's a camera. And now we can start to think about the fact also that usually the region label here is configured, right? So it's usually someone who is in charge of the infrastructure. That's usually your Patrick, that knows the location of the sites in Europe. So they will label this with the region Europe. While the presence of a camera is actually something we can programmatically figure out. We can see, for example, through something like a Linux operating system, DMI, or UDEV function, that there's indeed a device that is of type camera attached to one of the USB ports. So there's two layers here. There's the site layer, but also the kind of host layer. And then there's the configured knowledge, like region. And then there's the derived or the operational knowledge, like camera. So with that kind of combination, we should be able to, again, hopefully over time, fully short circuit or avoid actually meetings, or actually we can make this into an API. We can make this programmable. And what Platrix platform will have to offer then to meet that developer request is, of course, the ability to read the application specification, so it understands what the application should look like and how it should be instantiated, match on the host and site definitions, and then, of course, deploy the resulting applications to the resulting sites and actually to the resulting hosts in the sites. And under that there's a couple of other features that's usually required to make this comfortable enough. And one of them is what we call a canary stage. Usually you don't want to deploy, if you're deploying applications to hundreds or even thousands of locations, you usually don't want to thundering herd that. You want to run in a location or two, maybe in a lab site, or at least some sort of site that is close to where the team is located, just to make sure that this new application or even new version works well. You need some sort of host scheduling, so you need some understanding of, in a site, which are the hosts here. You need to be able to provide secure networking, which can, in certain cases, be a little more maybe complex than what it looks like. So you need to be able to protect data running between containerized applications and between services and between tenants, if you actually provide tenants, both inside of the site, but also between the site and usually some sort of central or several central locations. You need secrets distribution. So, of course, if you do secrets management in the cloud, there's usually a single cluster, maybe two. Here, you're looking at maybe hundreds or thousands of locations, and you certainly don't want to distribute all secrets of all applications to all locations. You want to only distribute secrets related to a particular application to the locations where they are, or where the hosts carrying those applications are. And you need some really well thought out through health probes. That's a broader topic, like what is it that we need to measure on if we want to give some sort of top level understanding of the health of an application, if it consists of replicas running in maybe thousands of locations. What kind of data do we need to pick up? How do we actually combine that so it makes sense to someone? And how do we make sure that it actually ends up in front of someone who's in charge of managing the application? But if we have a platform that can do that, we can actually then deploy this application. And again, note, we will be able to do this without involving our friend Platrix at all, but we should be able to provide whatever comfortable environment that Applifer is used to. So maybe a command line interface, or a web UI, or maybe a set of REST endpoints that she can integrate her existing tooling with. But in order to do that, you will have to extend, of course, that declarative side of things to include things like where. And of course, this is a good segue into the demo that I've prepared for this presentation here. So I'm going to flip to my correct web UI. And it's this. So what we have here, in order to kind of support, of course, the setup that we've done through the presentation, is an example based on our offering of what this can look like. So a suggestion to what the structure can look like in order to meet the requirements of an Applifer, so she can comfortably run her applications. But first of all, the first view that I wanted to show you here is the view of Platrix. So you should think of yourselves now as someone who's in charge of the infrastructure. And as an infrastructure person, of course, at the heart of your operations is the notion of different locations. So the first thing you see as an infrastructure engineer is the amount of sites that you have. So that's on the left here. We can see that there are, I believe it's 9 sites. And if we click on one of them, let's click on Chicago, we can see that this site consists of a single host. That would be the host here. And you can also see, kind of coming back to what I said about configured and inferred labels, at the top of here, we can see that Platrix, in this case, knows that this particular location, because this is actually a set of retail stores, has the need for shrinkage detection. So they want to do theft detection here. He knows that it's in North America. He knows that this site actually has a GPU available, and of course, it's in the United States. And we also have some gray labels here that is inferred from the system. And if we click through to the actual hosts, we can see a lot of details here that may be interesting for Applifer. She may want to target things that have a particular amount of resources available, maybe a particular architecture, all kinds of things that she may want to use in order to place her applications. And of course, as a Plattrick, what you want to understand is, how is this host doing? Do we have enough resources available that it's safe, if you like, to allow Plattrick to keep placing, or sorry, Applifer to keep placing applications on it, so that we don't run out of resources. And in this case, we've actually already placed a couple of applications, but that's actually Applifer that's done that. So as a Plattrick, you can also see that in all these stores, for example, we're running point of sales already. It's up and running, it's doing fine, and it's owned by an application team. So we can always see that these clusters or these locations are healthy, but they are running applications. So you should probably think twice before you do anything operationally to these. And we have a single location here where we have 3 hosts, for example. And in this case, you can see that there are services running on 2 of them. So this number 3 host here, you could actually take out of operation without impacting the others. And that's the kind of view that Plattrick needs. He needs to understand, how are my locations, how are my sites doing? What is the actual nature of these sites? What kind of equipment do I have here? Is there anyone running any applications here? And if so, where are they running them? So in this case, again, he understands that we have a combination in some locations of a point of sales application and a HiveMQ and MQTT broker running on these sites. So probably should be careful about them. This is a up and running and operational system. Okay, so that's that about Plattrick. Now, this is great. He has this system. He has now offered this to our Applifer. So I'm going to switch to an Applifer view here. So this is the view of Applifer. It kind of looks the same. It is in the same system. It's just that it's geared towards the needs of Applifer. And what she usually does is that she has more of an application-centric worldview. So she wants to see a list of the applications that are available to her. And of course, she wants to be able to figure out which of those are already in production. So we can see that we have a couple of applications available in the system. And we can see by looking at the green dots here that 2 of them are up and running. So we can see that our HiveMQ broker is up and running in a couple of locations. It's version 1, the status is fine. Same thing with point of sales, is running actually all over. That's actually in version 3.1, and the status is up and running there as well. Now, that's all good and well. She can see the sites, but she is, like Amy said, way less interested in the minute details of the hardware configuration. But she is very interested in the labels here, because this, you can think of this as kind of the where-based contract with her Plattrick. So they may have conversations about what kind of information from each site, or maybe even from each host, do you need insight into, because you need that kind of information to place your applications. And I mentioned that we have, for example, GPU available here. So anything that requires a GPU, she can safely match on that, and it will be only placed on hosts that actually support it. So let's do that. Let's see if we can actually get this going. So what we're going to do now is we're going to look at one of the applications that we have prepared here. And we are going to deploy this to Plattrick's infrastructure. And you will notice that there will be no phone calls or Zoom calls during this demo, but we will do it fully declaratively. So we're going to use a very simple application that I call Visitor Counter. Again, it's been preloaded into the system, and I'll just show you really briefly what it looks like. So if you look at the right side here, you can see that this is, of course, a YAML, in this case, based on the same structure as you usually have with Kubernetes pods, or for that matter, Docker Swarm files. So it describes a name and a version of the application. We're going to use a single image in this case, and that's hosted in our demo registry. So we're going to pick that up from our registry. And there's a couple of things to do with readiness probes and other things here that makes this a simple but kind of robust application. And the thing here, of course, is that we've only configured this. So we have taught the system about the what here. So the system now knows this is the application that I will eventually deploy whenever I'm told where to deploy it. And as part of the preparation here, of course, we've made sure that we could pull in the images so we can see that we have found the constituent container image. It's present. The digest looks fine. And we are now ready to deploy. And the way we do this, again, then, is we look at a specification for deployment. We can see that there's already one for the HiveMQ stuff and for the point of sale stuff, but I will create a new one for the visitor counter. And this too, right? This step or this artifact is also declarative. So we're going to give it a name. We'll call this visitor counter deployment. And we're going to point it to an application. In this case, of course, we care for the visitor counter application, and we're going to pick a location. We're going to pick 1.0. And then we're going to use that label matching to say, in this case, we'll use the GPU available equals true. And since we already know from Plattrick that those are only the sites that actually has a GPU available, and I know that our visitor counter application has the need for a GPU to actually make accurate counts, that sounds like a good thing. So we can see here that we're matching on 6 sites. We're not running on any of them. This is an idempotent system, so we don't have to care about the fact that there might be a running set, but we're going to do a net out of 6. And we want to be careful. So we're going to use a canary stage here. And we're going to use a manual step. And let's say we'll use region equals Europe for this. So that's going to be 2 actual locations in our manual canary step. So what I've done now is that I've, of course, complemented the what with the where. And I've actually also added a little bit of kind of deployment feature here, which is to say that's the target state, those sites. But let's go through a canary stage first. So we're going to submit this deployment, and now the system understands both what, but also where. So now we can see deployment starting. And of course, we're going to start with deploying to our canary sites. And when they are up and running, we want to actually make sure that it works. And again, since I am a applifer here, I want to click through to this location, but I want to click through to this location and look at my application running here. So here's how I can look at the actual instance of this application. We can see that the application is up and running. It's got a service. It passed all the startup probes. It looks good. We look fine. There's only a single container. Again, went through all 3 probes. We may want to actually, let's look at some logs first. So I want to see the logs not only from this site or the hosts, but we want to see the logs only from this application in this location. So in this case, I'm going to ask the system to show me those logs, but since maybe 3 minutes, just to make sure that the application came up and is giving us useful data. So it's giving us a visitor count here. So that looks like a good thing. I may also want to actually access that container. So open a terminal, not the host, of course, that's Plattrick's domain, but I want to, open a session towards my running container. So we're going to do it like that. So in this case, I can do whatever I want here, since it's a shell inside of my container. We can take a look at the process list, and we can do something mean, like we can kill the command process, which will exit the container, and the local scheduler will figure that out, and we'll make sure that we're passing through the probes again to make sure that we can actually come up successfully after an exit. So we did, that's fine. And we can look at the logs again, maybe, just to make sure that we can see useful data again. Yep, and then we can see the restart, and we're back to getting visitor counts. So that's good. So as an applifer, I'm now more confident that my application is it's giving me good data. We can even give it a nice little trip up, and it will get back, and it will give us nice data again. So that gives me enough confidence to go back to the deployment and say, please go ahead and actually continue the deployment to the other sites, which will start the deployment, and in a moment here, we'll be up and running. Again, please note that there are no interactions with a Patrick. We've let the system figure out where to deploy these things and how to do that, and it's given us access enough that we can be confident that our applications are running. And maybe in some mature environments, this is actually something you allow your application teams to do, but usually in our experience where it becomes more complex is kind of day 2, if you like. That is when there's a new version of the application coming out. So Applifer now publishes a new version of the container in this application, and she wants to get ready to deploy a new version of the application proper. So she updates or prepares the system for an updated application. In this case, she updates the what. And of course, we don't know where to deploy this new version yet, but we want to make sure that we actually see the image and that we are fully prepared. And now that we have full control as an application team over both the what and the where, we can then, of course, go to the deployment, and we can do something interesting. We can do things like, actually, this new application can run without GPU. We made it very efficient. So we want to run it everywhere. So we can say system type equals edge, which is a magical incantation in this case to say in all locations, because we were very happy with it. So now we're matching all 9 sites, and we were already running on 6 of them, so we'll do a net add of 3. But we also want to do an upgrade, right? So we want to actually now start running version 2. So we will inline upgrade or replace the existing instances of version 1 with a version 2, but we're going to make a fresh install of version 2 in three new locations. And again, the end state here, the combined what and where, is going to be version 2 running everywhere. And usually for some of our users, this is actually not a couple of hours, this is a couple of days, because it becomes a very, very heavy manual experience. So we're going to keep the canary stage. We submit this updated deployment, and we can watch it happen. Again, we're going to do 3 canaries. 2 of them will be upgrades. 1 of them will be a fresh install in Stockholm, which is a 3-host site, so usually it takes a couple of more seconds. And what we also will start building here is a trace of events and history. And I'll show you that when we've done the deployment. So we're all up and running. Because as an Applifer, again, your worldview is not so much, here's a couple of locations or a lot of locations, where are my applications, but rather the other way around. It's an application-centric view where, as an application owner, in this case, the owner of the visitor counter, you want to see all events, for example, pertaining to this particular application across the infrastructure. So in this case, we can start asking for all the events related to this particular set of applications since 3 minutes. And in this case, of course, you're going to see a lot of deployment events, but it's going to be fetched and exposed independent of whether it's in a single location or in very many locations. And the second thing, of course, you want a history. You want a history for this particular application, independent of whether we started with a single site or a single host, or if we did it across the entire board. And of course, you want to do that because you may want to roll back or just understand the history of the application. And maybe as a final touch, with this application worldview, what you also want to do is have the ability to look at logs from all instances of this application. So maybe we now want to see a visitor count from all locations that are actually running this application. So we can do an application-wide query here, and we can say we want to see all the visitor counts from all locations since 2 minutes. And of course, we're going to start receiving a lot of visitor count data because we're now running in a number of locations, or 9 locations to be very specific. All right, so what we've done now, of course, is that as an Applifer, we've looked at some applications, we've looked at what kind of sites we have available and the contract labels that we have from our Platric. We looked at a new application that we didn't actually have in flight yet, and we contributed that kind of new part of the abstraction that Amy mentioned, which is the where, under which circumstances. We deployed a version, and then we came to the realization that there's a new version and the deployment constraints have changed. We can now run it everywhere. So we declared a version 2. we expanded the deployment scope, and we upgraded the applications that were already running. And again, we did this with a strict application view, and maybe more importantly, we did this without any phone calls with our Platric. With that, I'll hand it over to Amy.
So to conclude a little bit, when you're creating a developer self-service experience for edge and or IoT environments, it is very important to focusing on finding the right level of abstraction. And that is the right level of abstraction depending on which user you are or which user you're asking. An applifer should, for example, not having to worry or care about infrastructure-centric details that do not provide her any value in her way of working. Also, do not default to attempting to use the tooling that you already have in place for the cloud, also for the edge, because it is quite different. It might look similar if you squint a little bit, both is container orchestration or container management, but there are characteristics and unique things to take in consideration between the cloud and edge that are very, very different. And that matters when picking the right tooling. However, once you've found purpose-built tooling for the edge, make sure that you can reuse the relevant or the appropriate investments that you've already made in the cloud and extend those capabilities also to the edge environments. And that is how you build a developer self-service experience for edge and IoT in the long run. We are happy to answer any questions, and Barbara are super happy now that we've found the right level of abstraction. And otherwise, we'll say thank you. Maybe, Carl, you can jump to the next slide. I think there are some contact details for us if any questions come up afterwards. And just to mention, this tool that we're using here, it's available for a free trial on our website if you have applications that you are attempting to deploy to the edge yourself. So that is good to know.
All right.
Thank you.